because this whole session was about feedback in realistic environment simulations.
Yeah, I have a question. I had a question. Of course, you know, it's nice to have realistic feedback, but realistic feedback is not necessarily the correct feedback. So, my question is, there is a lot of data out there. For example, at high redshift, we know a lot of information about the circumgalactic medium of Lyman-Break galaxies, right? Abundances of several ions. And this is not a question for you, it's just a question for everybody doing the fire simulation. Stidel galaxy survey, we know the equivalent width of several ions as a function of impact parameter. And I haven't seen a comparison between your simulation and that type of data, which is something we tried a few years ago already. So perhaps it's out there in the literature and I haven't looked at it. But it'd be nice to check your feedback scheme against that type of observations.
I'll bring the...
I can answer without. Yeah, that's a fair question, and I actually have read a student really long that it's working on a pipeline to look exactly at these things. And there are students at Northwestern also looking at these things at lower redshift. So hopefully in the next 6 months we'll be able to say something more about it. But it's a completely fair question. There is lots of data, and now in the last year we actually built a much larger sample of high redshift galaxies that are evolved only down to redshift 2. So we should be able to address that much more.
I actually would love clarification also from you and from Piero about the difference between realistic and right, because as an observer, I'm trusting if you tell me you're doing realistic, it means that actually you're trying to reproduce the reality. So can you clarify on what ground is realistic and on what ground is not right? I'm lost.
Actually, I think this is the kind of question that's going to be discussed over lunch, because this is a never-ending discussion. It's a strong function also of resolution. So, was there a simpler question from...
I think I will come back to this, actually. No, so I think this morning we've seen a lot of beautiful simulations, and but a lot of qualitative statement about the realism of the feedback. And okay, unless I missed something, as far as I understood, the fire simulation doesn't do photoionization radiation transfer, doesn't do infrared dust radiation transfer. So okay, it's just you know, subgrid physics, and it's basically a very expensive semiotical model in terms of feedback, right? So I want to put things in perspective. It's probably the best feedback model around, but it's still a subgrid model. So a lot of people have mentioned qualitative statement about and comparison with respect to previous work. I think qualitatively it's exactly the same as the previous work. And I want really to stress that, right? It is not ab initio simulation, okay? If you want to do ab initio simulation, you need to do photoionization additive transfer and dust infrared additive transfer. You are not doing this. No, I'm just focusing on stellar feedback because this is what it is about, right? Stellar feedback has not been modeled self-consistently in the FAR simulation, and I want everybody to, you know, accept this, right? You can say qualitative statement about previous work, but it's not fair. It's not honest.
Okay, now I think we have to give Dusan a chance to respond. And then I think we should stop for lunch. So.
I mean, that's partially fair statement, not completely. So we do have a very crude approximation how to do photoionization and how to do infrared RT. So we are measuring column densities and approximately trying to estimate what's going on. We don't have full RT. Also for photoionization, we are calculating the size of strong spheres and trying to overlap them if we have many sources. But again, it's not full RT. But we are trying to do as good as possible and implementing physical processes that we know are important in those scales. And I completely agree, at the small scales, we're always going to be at some sort of subgrid model level. It just depends at what scale you're implementing your subgrid and in what sense you are having subgrid. The advantage of this, which I think comes with respect to previous model, is that the scales at which we are doing subgrid, or the parts that are subgrid, are at much smaller scales and much finer level than before. So you can try to, quote unquote, predict what will happen with the ISM or with stuff close to the galaxy, which you wouldn't be able to do if you just launch particle outside of galaxy to start with. Because you tell the particle what to do. Now we are trying structure of the galaxy, hydro, gravity, and these crude prescriptions to actually see what's going to happen with the evolution of this particle as it moves through ISM and a little bit out. So I would agree with you, we are not there yet, we are trying, and at some level all of the models, and practically they will always be at some subgrid level. We would have to go to the actual resolving individual stars and maybe even atoms to actually get out of the subgrid in some sense.